Welcome to the Battery Testing Mentor podcast. My name is Johannes Rössmann and here I discuss all topics around battery testing and battery handling. Short, on the point and with actionable advice. Also visit www.batterytestingmentor.com and sign up there for the email summaries. With every episode you get the key takeaways into your inbox. And if you have any comment, question, remark, or wish for a new topic, just hit reply there and you directly reach me. With that, enough of the housekeeping, let's get into the episode. How does a lithium-ion cell work? One idea that often comes to mind with people is this idea of the plate condensator from school. I know I have seen it back in these times when I was in school. It was pretty analog. But this is, to be honest, the wrong idea. A battery cell works completely different than a capacitor, basically. So we think about something else, and then another nice story that you hear as a kid is always the lemon, where you put two metals inside and connect it with a wire and a lamp, and suddenly the lamp goes on. And basically this is already the key elements of a battery that you have in there. You have two metals that are basically connected with an citric acid, like some acidic fluid, and then of course you need to connect it with a wire and the lamp. In this example we have the two metals of copper and zinc. The zinc electrode gives away the electrons very easily, and in the copper the electrons flow back and then they recombine via the citric acid. And taking this, I will draw here together with you now a battery cell. The first thing that we need is the two metals. It should be two different metals. If you take the same metals and put them into the lemon, nothing will work because you have not a different electrochemical potential. Ideally, these metals should come from kind of different sides, be pretty far away on the periodic table. So on the one hand, you have elements like this lithium. Sodium is also one. Sodium is the one that is now in the press since last year for a kind of game changer battery for kind of simpler applications. Magnesium. Be careful not to mix it up. These are metals that are have only one outer electron in their kind of configuration, and they can release this electron very easily and then turn into a positively charged ion. So basically lithium ion is a positively charged ion. This electron, let's draw it here. We have the lithium going into a lithium ion, and we have then the electron being in the current collector. And now basically this electron is traveling outside the cell to the other side of the cell, the other metal, where the lithium ion, the ion in generally, is staying inside the cell and moves inside the cell to the other side. You often have this material combination. The other typical material that you have in there is like fluorine, chlorine, sulfur, oxygen, carbon, silicon, and they help kind of make this reaction possible. This is kind of in the lemon where the zinc would play a role. These elements are then often found in the right side of the periodic system of periodic table, and they often have like kind of fewer empty spots in the outermost bond. We have the anode and the cathode. What does this, or where does this come into play? So on the anode, these materials release electrons. So that means here we have the anode where the electron during the discharge is released, this is where the oxidation happens. So the oxidation is kind of this process that is releasing the electron. With the oxidation comes always the reduction. So we have here on the other side the cathode, where the reduction takes place. I hope you excuse my writing. It's always a little bit tricky for me on this iPad. There is also some things to remember. What is the reduction? What is the oxidation, and where is the anode and the cathode? There are some mnemonics. One is oil rig, very suitable for a battery, but it means oxidation involves loss of electrons, reduction involves gain of electrons. Another one is the red cat and an ox, which means the red reduction is the cathode, the cat, and the anode is the oxidization. Then the next question is, where is plus and minus? The anode is the minus pole, the cathode is the plus pole. This is also important to remember because the technical direction of current is the other way. Like technically you say the current goes from plus to minus, but the electrons travel from minus to plus. The reason for this is just that people defined the direction of current before they really could understand the phenomenon, and then once they understood it, they didn't want to change anymore. Yeah, with this we have the rough elements. We have here the electron. Of course, the lithium ion is then traveling in between while the electron is traveling. What else is important? I mean, one thing is you want to recharge the battery. Like a lemon, you can't recharge. You put these things in, and then at one point it will be all like kind of used up. The zinc will be used up, the copper will be used up, the acid will be used up, and then it dies. On lithium ions or lithium ion battery, you can recharge the battery. So this is also important because that doesn't mean the lithium is bound to the anode or the cathode, but it travels back and forth. Here in this graph we have the discharge. When the discharge is taking place, the lithium ion travels from the anode to the cathode. For the charging, it travels back, and with this also the electrons travel back. It's also the point that lithium is not really appearing in this metallic form, in the pure form, but also in compounds. You have really a big mix of material inside the cell. Typically there are on the anode side elements like carbon, graphite, silicon, lithium titanate inside that help store the lithium ions. On the other side, we have the cathode, and their materials that are there is often metal oxides, like lithium cobalt oxide is one example. NMC, this material, nickel manganese cobalt oxide, is there. There are also lithium iron phosphate, for example, is on the cathode. So you noticed maybe already that both materials involve the name lithium sometimes. There is in both sides sometimes lithium. This is because the lithium is just brought into the battery by this material, and then it starts traveling, of course, back and forth. Another important point is you need the conductor. I mean, I assumed it here already that we basically have the conductor on the anode side and the conductor on the cathode side, and there the electron kind of travels outside of the cell. Typically these conductors are copper and aluminum. These are used because basically you'd want a conductor that has a good connection to the active material, and at the same time does not participate in this process. It is not attacked by the materials, it's not corroded. It really needs to be there and kind of have this good connection to the active material for the whole time. So with a lot of research, they found out copper and aluminium is the best way to go. Copper is typically on the anode side. Here on the cathode side, we have typically aluminum. And then you basically have now the solid material put together. Of course, a key point is these both sides, cathode and anode, should not touch each other. Should be separated, but still the lithium ion needs to travel back and forth. And the lithium ion doesn't just travel through the air, but therefore there is typically an electrolyte put into the cell, and that is soaking the whole cell. It's connecting really basically the anode and the cathode, and makes it possible that the ion travels from one side to the next. This electrolyte is really a mix out of a lot of different chemicals. There are things inside like ethylene carbonate, abbreviated as EC, and there's PC, propylene carbonate, there's DEC, dimethyl carbonate, and then there are conductive salts. Like these are compounds with lithium inside, like lithium hexafluorophosphate, and they help to that there are enough lithium ions there and that they can travel from one side to the other. They kind of take care of the conductivity. With that, we are still not yet done, because in the middle there's also, let's take here, right, a separator that is basically going through the battery, and this is making sure that the lithium ions can travel through there, but no electrons. The electrons need to go across the conductor, across the cable. This thing that is here in between the separator and the electrolyte, they need to be very, very robust. They need to withstand the voltage potential that is in between the sides. They need to work with low temperatures, with high temperatures. They should not get solid. They basically need to make the cell work during the whole time. And they have a lot of positive traits, but they also have a disadvantage, and that disadvantage is that they are potentially flammable. I mean, not potentially, they are flammable. And if they really heat up, they evaporate, some vapor is generated, and this vapor can easily be incendied if there's a spark. And you have this fireball that we talked in the second episode of this podcast about. So looking at this, do we have the complete cell? Basically, yes. What is of course missing is a case around. I won't draw it here because the picture is already quite full. To make sure that everything is tight, is protected from the outside. There's really no exchange between the inside and the outside. No air coming in, no humidity coming in. It's really super tight. And to be honest, this was now a very, very theoretical exercise. In a real battery, you have then, of course, other things as well. You might have some elements like a vent, for example, to make sure that the battery performs under certain conditions also as expected. Maybe this is another episode worth to take a battery, a real cell, and disassemble it and look at all the components that are there. With that, I hope you enjoyed this trip into the chemistry. I hope it got a little bit clearer to you how a lithium-ion cell works. I wish you a good week, and hear you next time at the Battery Testing Mentor.